To actually deduce the equations of motion, we first have to know these basic things. So first, know that U is for initial velocity, V is for final velocity, or what some people would just say velocity. Now, A is actually for acceleration, and T is for time. Okay, so knowing this means you are ready to go. So let's proceed. So to deduce the equations of motion, to deduce the equations of motion, let's first start with this equation, and it says acceleration is equal to that's change in velocity over time taken. Now we can simply write it as A is equal to change in velocity means what? Final velocity minus initial, and then time taken will be what? T. Okay. So knowing this, we can actually get the first equation of motion, and we cross multiply, right? So this will give us A times T, right? So A T, and then that will be equal to V minus U, right? Okay, so we make V the subject, we make this one the subject, so that will give us V is equal to, we send this over to this side, that will be AT plus U, or it can be V is equal to U plus AT. It's the same thing. So that is actually our first equation of motion. Okay, now we would want to know the other equations, but first we have to know that average velocity is equal to total displacement all over total time taken, right? Okay, now with this equation we know that the total displacement, so let's write it, that the velocity, the average velocity we said earlier, is equal to what we say the total displacement, and total displacement is actually represented with S. So let me write that before we continue. So displacement is the same as small s, right? So here we can say that the average velocity is equal to the total displacement, which is small s, all over time, right? And with this same average velocity, we can say that it's equal to v plus u, right? That's the final velocity plus the initial, all divided by 2, right? It's another way of finding the average velocity. So we have two ways. The one which is let's name it A, that's equation A. So average velocity can be, this is it, can be the displacement, which is small s, over time, which is small t. So we knowing all this, we know that that same average velocity can be found this way. So this can be our equation B. And as we can see, because they are all average velocity, we can say that they are equal. So we can say this should be equal to this. This should be equal to this, right? So then we can say S over T is equal to V plus U over 2, right? Now, getting this, we can actually find the displacement, which is small s, right? So let's say S is equal to V plus U over 2 all times T, right? And let's say that is our equation C. And from the equation 1, right? From equation 1, which is V is equal to U plus AT, we can actually say that V minus U all over A is equal to T, according to the equation 1. So we actually substitute this T right here into the equation C. So you substitute T into equation C, right? Okay, so after substitution, we will realize that S will be equal to V plus U all over 2 times the T, right? We are substituting the T, which is V minus U all over our A. Okay. Now we can find the S, which is the displacement, and that will be equal to V squared minus U squared all over 2A. So we just multiply this and this to get this, and we multiply this and this to get this. So we multiply this and this to get this, right? Okay. And we multiply this and this to give us this. Okay. I hope it is well understood. So now we have this equation. And from this, we can actually get the second equation, which is V squared is equal to U squared plus 2AS, right? Okay. So that will be our equation 2, right? Okay. So getting that equation means we can actually get that of displacement, which is small s. So we can substitute the equation 1 into equation C, right? So this, let's go back. So we substitute this equation here, right? V is equal to U plus AT into this equation C, right? So we substitute it into this place, which is equation C. So let's go continue. So we substitute and we will get S is equal to U plus AT plus U all over 2, and then T, right? So S will be equal to 2U plus AT all over 2, and with your T. Okay, so this will be equal to our S, which is the displacement, will be equal to 2ut plus at squared all over 2, right? Okay, so finally our S can be ut plus half at squared. I hope you understand how we get this, or how we got this, sorry. So this, right, let me take you back so you understand it really well. So let me clean this. Okay, so here we are saying that S is equal to 2ut all over 2, right, plus at squared all over 2. We just separated it, right? I mean, this denominator is what we use here and we use here, and then we just divided it, right? Okay, so now that you understand why I did it like this, let me continue. So this will take out with this, and we will have S is equal to ut plus half at squared, and that is our equation 3. So you have all the equations of motion, the 3 equations of motion. So 3 equations of motion, which are 1, V is equal to U plus AT, 2 is S is equal to UT plus half AT squared. And then the third one is V squared is equal to UT plus, that is V squared is equal to U squared plus 2AS. Okay, so these are actually the 3 equations of motion. I hope you did understood all that I took you through, and please, if you don't understand anything, please comment in the comment section below. Write something in the comment section below and I'll get back to you. Thank you for watching and have a good one.